Hi, this is Math 7 Unit 6, Lesson 13, called Reintroducing Inequalities. And for those of you that are new to this series this year, reintroducing means going back to 6th grade because that's where you were first introduced to inequalities. So we're going to be talking about inequalities today, and that means we're looking at things like greater than and less than. Okay, and so back when you were in 6th grade, you talked about a number, so we call it x, being greater than some other number, or a number being less than another number. And these were things you talked about in 6th grade. And today we're going to be looking at the same concept and then expanding upon that for our 7th grade standards. So it says, first of all, greater than 1. The number line shows values of x that make the inequality x is greater than 1 true. So these values here, everything that is from the above the 1 on, are all values that I could put in place of x that are greater than 1. So it says select all the values of x from this list that make the inequality x is greater than 1 true. So it needs to be a true statement. So we're basically doing some substitution here. So would you say that 3 is greater than 1? Well, here's 3 on the number line, and it definitely is larger than the 1 value, so that would be a true statement. That's going to be okay. Negative 3. Well, negative 3 is over here. Is that greater than 1? We would say nope, it's not. How about the number 1 itself? Is 1 greater than 1? This is an interesting one because what we're saying here is if 1 is it, 1 is greater than 1? Not really, is it? 1 is equal to 1, but 1 cannot be greater than itself, so this would not be true as well. 700 would be way over here on my number line, continuing on there, so 700 is certainly greater than 1. That's true. And then even 1.05, even though it's only 500ths greater, is still greater than 1. That would be true as well. So we would say A, D, and E are all true inequality statements in terms of x being greater than 1 and substituting those numbers in the place of x. Okay? And it says number 2 here, name 2 more values of x that are solutions to inequality. And in this case here, any number greater than 1 is going to be a solution. That's what a solution means. So any number greater than 1. You could pick 4, you could say 5, so 4 would work, 5 would work, 300 would work. Anything greater than 1 is going to work there. And it doesn't even have to be a whole number. It could be 6.8754321. Who knows? Anything you want, as long as it is greater than 1, would actually work to be a solution for that inequality. In our next activity, we started talking about this roller coaster activity, and it says that a sign next to a roller coaster at an amusement park says you must be at least 60 inches tall to ride. Now notice it says at least 60 inches tall to ride, which means you can be 60, or you could be 61, 62, and so on, but you need to at least be 60 in order to ride. Noah is happy to know that he is tall enough to ride. So we know if Noah is tall enough to ride, he has to be at least 60, but he could also be more than that, couldn't he? So number 1, it states that Noah is X inches tall. Which of the following can't be true? So for Noah's height, is Noah going to be greater than 60? Well, we're going to say yes, that's going to be true because we know he is tall enough to ride. So whatever value x is, it can be greater than 60. That's going to be fine. Looking at this next one, x is equal to 60. If Noah is exactly 60 inches tall, can he ride the ride? Sure he can. You have to be at least 60, so that could work too. So he could be just 60. He could be greater. He could be exactly 60. That would work. How about x is less than 60? Can Noah be less than 60? Can he be, say, 59? In that case, we would say no. He can't be less than 60 because we know he can ride the ride. So it has to be 60 or more in this case here. So we're looking for 60 or more to actually work to be a solution for this equation, or for this situation here. It needs to be more than 60, or 60 or more, sorry. In the second statement, it says here that Noah's friend, Noah has a friend, is 2 inches shorter. 2 inches shorter than Noah. Can you tell if Noah's friend is tall enough to go on the ride? That's our question. Can you tell if he's tall enough? Now, first of all, do we know Noah's height? We don't know. So when it comes to our first thing, we don't know how tall Noah is. If Noah was 60, right? So if Noah was 60 inches tall, what would his friend be? Then the friend would be 2 inches shorter, which would be 58, and that would be no, can't ride the ride, right? So if Noah was 60, he wouldn't be able to ride the ride. If Noah was 62 inches, then the friend would be 2 less than 62, that would be 60, and we would say yes, he could ride the ride. But the problem is, we don't know how tall Noah actually is in order to determine how tall the friend is going to be. So we really can't answer that question because we don't have enough information. List one possible height for Noah that means his friend is tall enough to go on the ride, and another that means his friend is too short. All right, so for the tall enough, okay, for the tall enough, meaning you have to be greater than 60, right? Or you could also be equal to 60. We could say that Noah, if Noah was 63 inches, then the friend would be 2 less, 61, and that would work. For the not tall enough, or too short, or not quite, too short, we could say that Noah is 61 inches. And if Noah is 61 inches, then the friend would be 2 less, and that'd be 59 inches, and that's too short. Not gonna work there. Okay? Those are just numbers. You can pick up any number you want, but the thing is, whatever Noah's gonna be, for this to work for the friend, Noah would have to be greater than 62 or more. For it to not work, Noah it's going to be 61 or less for it to not work. That's the idea. On the number line below, show all the possible heights that Noah's friend could be. Okay, all the possible heights that Noah's friend could be. Now, Noah's friend could be lots of heights. We know for Noah we know can ride the ride. Noah could be 60 inches or more. That's for Noah, because he's able to ride the ride at 60. So since Noah can be here or more, the friend we know is 2 less, 2 inches shorter. So the friend could be 58 inches, right? And because we include 58, we're actually going to shade in that circle, not keep it open. He could be 58 inches or greater. And so we'll color this line here and draw an arrow going that way forever and ever and ever. So Noah's friend could be 58 inches or more all the way through. So Noah's friend is y inches tall. Use y and any of the symbols less than, equal, or greater to express his height. So what we could say is that Noah's friend is y is going to be greater than 58. We could also say y can be equal to 58. And part of today's lesson is recognizing that rather than say this 2 different times, I can actually combine these 2 together to say for Noah's friend, it could be greater than or equal to 58. And that's the new way of writing this new term inequality for the day. We can use this little notation for greater than or equal to, just like you can also do less than or equal to. And so that's maybe a new thing for you to look at today, and that's a new thing we're introducing, something you can say. So rather than say something twice, we can combine those 2 statements into one to say y is greater than or equal to 58. And that's true for the height of Noah's friend. Let's take a look at the next side, which is activity 3, called Is the Inequality True or False? So this table shows 4 inequalities and 4 possible values for x. Decide whether each value makes each inequality true, and complete the table true or false. So we're going to write true or false, and then see what you think and talk it over with your partner. And if you disagree, work at it to reach an agreement. So we're going to take the numbers up here and we're going to put them in the place over here. So if I use 0, is 0 less than or equal to 25? I'm going to zoom in here real quick just so we can get a nice clear shot of the table here for you. So is 0 less than or equal to 25? That is true. If I put 100 here, is 100 less than or equal to 25? That's not true, that'd be false. How about negative 100? Is negative 100 less than or equal to 25? Yes, it is, so that'd be true. And is 25 less than or equal to 25? It happens to be equal to, so that would also be true because it is equal. On the next one, this row here, we have 100 being less than 4 times 0, which is 0. Is 100 less than 0? No, it's not, so that's going to be false. Is 100 less than 100? No, it's equal to it, but in this case, we see our sign, we just use a less than, so make sure you're being careful there what you see. It's not less than or equal to, so that'd be false. Oh, sorry, I gotta plug stuff in. Back it up here. Whew, just got ahead of myself. Back it up, back it up, back it up. Whoops. I gotta plug 100 times 4. 100 times 4 is 400. So is 100 less than 400? That is true. Sorry about that. Over here, we're still having 100. Is 100 less than negative 100 times 4? Negative 100 times 4 is negative 400. So is 100 less than that? No, it's not. That's false. And then finally, is 100 less than 4 times 25, which is 100? That would be false, okay? It's not equal, it's not less than, it's actually equal, sorry. It's equal, so we have to say it's false. The next one, we have 0 times negative 3, which is 0. So is 0 greater than negative 75? Actually it is, right? It's true. 0 is greater than a negative number, or 75. For the next one, 100 times negative 3 is negative 300. Is negative 300 greater than negative 75? Nope, that's a less number, it's less than, so that would be false. Negative 100 times negative 3 equals a positive 300. And is positive 300 greater than negative 75? Yes, so that'd be true. And the next one, 25 times negative 3 is negative 75 greater than negative 75. And in this case, that would be false because those are actually equal, not just greater than. And our last one here, we have 10 being greater than or equal to 35 minus 0, and that's just 35. Is 10 greater than or equal to 35? Nope, that's false. 35 minus 100 is going to be 65. So is 10 greater than or equal to negative 65? Sure it is. If the positive number is greater than a negative, that would be true. And then let's see. Now this is 35 minus a negative 100. So that means we're adding it up, right? Adding those together. So is 10 greater than or equal to 135? Nope, that's false. And then finally 35 minus 25 is 10. So is 10 greater than or equal to 10? It's actually equal, so that would be true. Okay, so a variety of little situations there where you're taking a value of x, plugging it into the inequality, and deciding if it's a true or false statement there. Come back out here a little bit. All right, so we use inequalities to describe a range of numbers. So not necessarily one answer, but a range of numbers starting from one place. Okay, and so when we look at things like a driver's license, a driver to drive a car needs to be at least the age of 16. So it had to be at least 16, but it can also be greater than 16. And so we fill in that circle at 16 to say you can be equal to 16, and then we draw an arrow this way to say or more. Okay, and that term, that symbol here, right here, is pronounced greater than or equal to, which combines two cases. It combines that the age has to be greater than 16, and it also can be equal to 16. And we show that again with that closed-in circle there. And that was really a little bit what today's lesson was about. So we're going to pause there as you take a look at your homework, and then we'll come back together to check it out. All right, homework. For each inequality, find two values of x that make the inequality true and two values of x that make the inequality false. So here's how I set mine up, just to draw it off a little bit. I went like this, and I wrote true, then I wrote false. I drew a line like so. I said, well, let's make up some numbers that make this work. Two trues and two false for each one of these statements here. So I want to find a value of x that I add to 3 to be greater than, I should say, 70. So if I had a number like 70 for x, 70 plus 3 is 73. That's greater than 70. It works great. I can also have a number like 100. 100 plus 3 is 103. That's greater than 70. To be false, I need something that adds to 3 to become equal or less than 70. So I could put a number like 30, right? Just make up numbers here. 30 plus 3 is 33, and 33 is not greater than 70. These are false statements here. And I can also put a number like 60, because 60 plus 3 is 63, and that's not greater than 70. These don't work. These are all bad ones. Okay, they're false. For the next one, something plus 3 is less than 70. So in this case, I could do 30, like it over there. 30 plus 3 is 33. That's less than 70. I could do 60, right? Same one from there. 60 plus 3 is less than 70. To be false, I could put a number like 70 over here, because 70 plus 3 is too big. I could also do 100, because it's going to be too big. This next one, we're multiplying by a -5 to get something that is less than 2. To be less than 2, I can do any positive number, and any positive number times a negative number is going to give me a negative solution, and I'm going to still be less than 2. So I could do positive 2, that becomes a -10, all right, -10. I could do a positive 3, because that becomes a -15. If I wanted to make it false, I could put a negative value in there, right, a -2, because a -5 times a -2 is a positive 10. That is not less than 2. And I could even do a -3. That would work as well. For this next one, because I have a positive number, I could do 5 times a -2, becomes a -10, that's less than 2. I could do another negative number, -3, that works there. And to be false, if I used a positive, that becomes 5 times 2 is 10, less than 2, nope, 2 not going to work. Or I could do a positive there. Again, there are lots of numbers you could use there. These are just some sample ones that I chose just for this illustration purpose. Number 2, here's an inequality. -3x is greater than 18. List some values of x that would make this inequality true. What would make this a true statement? And for this one to be true, x would need to be any number, in our case, less than -6. Okay, any number less than -6. So if I used a -7, -7 would work because -3 times -7 is going to be equal to 21, right? So that would work out just fine. 21 is greater than 8. I could use a -10. -10 times -3 is a positive 30. That's greater than 18. So as long as the number is less than -6, then we're going to be okay. Okay. Again, keep in mind your number line. If this is 0 and -6 is here, less than -6 means going this way. All these negative numbers going that way, right? There, down to there. Now, how are the solutions of the inequality -3x is greater than or equal to 18 different from greater than? So the difference so far is in this symbol, right? Because it can be equal to 18, I can use the number -6 is okay. And that's because -3 times -6 greater than or equal to 18 works out. This becomes 18 is greater than or equal to 18, and equal works out. That's okay to use. So for the inequality with the greater than or less than, I can actually use any number including -6 and anything less than that as well. But over here, I cannot include -6. It won't work. Okay? And that's the big difference there, is which one you can include. Okay? So for this one, I could use -6.1 and it would be fine, right? And so on. But over here, I'm allowed to use -6. All right, number 3. Match each sentence with an inequality that could represent the situation. Han got $2 from Claire, okay, but still has less than 20. So he has some money, and he got $2 from Claire, but overall he has less than $20. What does that match? It matches right there, number 3. May spent $2 and has less than 20. So she has some money, she spends $2 and has less than 20. It's going to match this one right there. Tyler had twice the amount of money he has. Tyler has twice the amount of money he has. If he had twice the amount of money he had, he would have less than $20. So that's 2x less than 20. And here, if Priya had half the money she has, she would have less than 20. So half the money she has will be less than 20. So those are the ones that match like so. Okay, let's turn the page and flip it over to the last couple of questions of today's homework. For number 4, it says, here are the prices for cheese pizza at a certain pizzeria. We have a small, medium, and large with some prices. You had a coupon that made the price of a large pizza $13. For what percent off was the coupon? Well, initially it's $16.25, right? So if I do $16.25 minus $13, I can see what amount of money I saved with whatever the coupon was. So doing some subtraction, you have $3.25 is what was saved. That's the savings. So if I take that amount, $3.25, out of the regular price, so divide it by the regular price, so my discount or my savings divided by the original cost is going to give me the percent off. So 3.25 divided by 16.25 is equal to 0.20. As a percentage, moving over 2 decimal spots, moving over 2 spaces, that's going to be 20% off. So that means if I was to take 16.25 and multiply it by 0.20, I'm going to end up with, in this case here, end up with 325. That's 20%. Okay, that would give me 3.25. If I took 16.25 and I multiply it by, let's go the other way, the 80%, because that's what I'd actually pay, I should end up with $13 there. Okay. B. Your friend purchased a medium pizza for $10.31 with a 30% off coupon. What is the price of a medium pizza without a coupon? Okay, so we know the price of this pizza is $10.31. That's the price of the pizza. But we don't know the original price. We're going to find out the original price of the medium pizza, and they used 30% off. So how much of the original cost did they actually pay? That's going to be 100% minus the 30%, which is 70%. And we write that as 0.70. So 70% of the original price will again give us $10.31. So when I divide this side by 0.70 and this side by 0.70, that will give me my original price. And 0.70 divided by, or 1031 divided by 0.70 ends up giving you 14.728. Because I'm talking about money, I'm going to round that up so that x equals $14.73. So I can write that up here in my table. And so letter part C, your friend has a 15% off coupon and they happen to have $10. What's the largest pizza they can afford? So to solve that, if we take a look at a 15% off, right, again, this is 100 minus 15 is 85% cost. Turn that into a decimal, 0.85. Let's go up to our table here. If they had a pizza for $11.60 and then you wanted to pay 85% of that cost, $11.60 times 0.85 is equal to $9.86. So they could definitely afford the small. If you took the medium pizza and multiplied it by 85%, which means 15% off coupon, that's going to cost you $12.50. So they could not afford that. So the largest pizza they could get would actually just be the small. And finally, number 5, select all the stories that can be represented by this diagram. Here we have 7 of something or other. We have 3 equal groups, and we have a 1 right there. So there's something going on where someone has 7 of something, but they do 3 x's or something 3 times plus an additional 1, and that combines to make 7. Let's take a look at our stories. Andre studies 7 hours this week for end of the year exams. He spends 1 hour on English and an equal number of hours on each math, science, history. Well, that's going to be 3 subject areas, right? So this could be 1 hour of English and then equal time in math, science, and history for a total of 7 hours. That would work just fine. For B, it says Lynn spends $3 on 7 markers and a $1 pen. Well, $3 is the total on 7 markers. I don't have 7 boxes there, so I don't see 3 being broken into 7 pieces. That's not going to work. Diego spends $1 on 7 stickers and 3 marbles. Again, there's a 1 and 3s and 7s, but the total should be down here, and I'm breaking that 7 up, which is not happening there. Noah shares 7 grapes with 3 friends. So we have a total of 7 grapes with 3 friends. It says he eats 1, that would be that 1 there, and gives each friend the same number of grapes. So he has 7, he eats 1, and then divides the rest with the 3 friends. That works. And then finally, Elena spends $7, number there, on 3 notebooks and a $1 pen. So this would help us know that she has $7, she has 3 notebooks, no cost, that's okay, and a $1 pen. So we'd be able to find out the cost of a notebook. That one would work there. That's it for today. We'll see you next time.